All right, today's lesson is on nth roots and rational exponents. So we're going to be looking at different types of roots or radicals. So you guys are used to this symbol, right? This is called the Radicand. It's the name of the symbol, right? Usually we're used to using that with square roots, but we are going to look at other roots as well. So usually when we write the square root, we don't write a little number in here. In fact, if we don't write a number in there, it's assumed to be a 2. But this number is called the index of our root. And it will tell us if we're taking a square root or cube root or fifth root, etc. So when we're trying to simplify some radicals, as we'll do in a second, that index number n tells us the size of the matching sets required to escape the radicand or to get out of our radical. Okay, so here's our first example. Simplify each radical, and we'll try 3 of these out. And our first one you would recognize as a square root, right? And again, if you don't see a number written here in this indentation, if you don't see an index written, it's assumed to be 2, the most common root or square root. What that means is we need sets of 2 to escape a radical. So if we looked at our factors of, say, 18, we could break that down as 9 and 2, and 9 breaks down as 3 and 3. So the prime factors of 18 are 3 times 3 times 2. And for a square root, we would need sets of 2 to be able to take anything out of our radical. And here we have 2 3s. So we get to take a 3 out of our radical, and anything that's left over would get multiplied and goes back inside of our square root. So we'll have our 2 left over. So notice I'm leaving a little space in case some of these variables come out as well. So speaking of which, let's look at our variables. X to the 4th means x times itself 4 times. So again, if we're looking for sets of 2, we've got 1, 2 sets of 2. So we get to take 2 x's out of our radical. X times x, or x squared. And because we've used all of them up, there's none that need to go back inside of our radical. Okay, very similarly for our last variable, y cubed, that means we have y times y times y. We have 1 set of 2, so we get to bring 1 y out of our radical, and 1 y left over, which would stay underneath or inside of our radicand. And so our answer is 3x squared y times the square root of 2y. That is as simplified as we can make it. Okay, for this one, we now have a cubed root, or a third root. And so what we need is sets of 3 in order to take anything out. So we need sets of 3 are required. Okay, otherwise nothing will simplify. So let's try breaking down 24 as usual. We could say that's 8 times 3, or maybe 6 times 4. I'll go ahead with 8 and 3. We could break 8 down as 4 times 2, and 4 down as 2 times 2. So all of our prime numbers are 2, 2, 2, and 3. And once again, if anything gets to come out of my radical, I need to have a set of 3 matching factors. And so in this case, we have 3 2's. So a 2 gets to come out of my cubed root. And we do want to make sure we write that cube, or that index number here. It is a cube root, not a square root. And this 3 that didn't have a matching set of 3 factors stays inside. Okay, now I check out our x. X to the 4th means x times itself 4 times. But again, remember we're looking for sets of 3. So from our 1 set of 3, we get to bring 1x out. And this leftover x stays inside or underneath our radicand. Lastly, we have y cubed, y times y times y. We're looking for sets of 3, so we do have exactly a set of 3, so we get to bring 1 y out, and there's no y's left over. So if we want to space these a little closer together, 2xy times the cubed root of 3x. Okay, let's try one more. So again, here we have an index of 5. We are taking the fifth root. So I need matching sets of 5 in order to take anything out. So if I don't have a set of 5, it stays underneath our radical. So 243, I think, is divisible by 3. So we can divide that by 3. That becomes 3 and 81. 81 we could break down as 9 times 9. And each 9 will break down as more 3s. 2 sets of 3s each. So we end up with 3 times 3 times 3 times 3 times 3. We actually do end up with exactly one set of 5 3s. So we do get to take a 3 out of our fifth root. And then we wouldn't have any integer left over. So next we look at our variables. X to the 6. Remember, there's 6 x's in here, and we're looking for sets of 5. So we can make one set of 5, bringing one x out from our set, and this guy left over stays inside of my fifth root. And lastly, we have exactly 5 y's. So we're going to be able to take one y out from this set of 5, and no y's stay inside. So if we write this a little closer together, we get 3xy times the fifth root of x. And there we go. So if you don't see an index written, remember that's assumed to be 2, a square root. If you do see an index written, that's what we need matching sets of our factors in order to take anything out. All right, the other part of our lesson today is on rational or fraction exponents. So yeah, we can have fraction exponents, and what they really mean is a type of radical or root. Okay, so let's take a look at our two different forms. So this first one is called exponential forms. This is where we're going to have our fraction exponent. So here, n, the bottom, we're going to call, is going to tell us the root of our radical. And a good way of remembering that is, where do you find roots? Underground, right? So you can think of kind of our division bar here as like being the ground, and the root is under the ground. That tells us what root or index number we'll have in radical form. And then m is the power we're going to raise that radical to. Okay, so let's take a look at specifically an example here. So if I had, say, x to the 3/2 power, in fact, let's use a number, 9 to the 3/2 power. Okay, well, this 2 is the root in the bottom here. So this tells me we're taking the second root, or the square root of 9. And the number up top, our power, is what we're going to raise that answer to. We're going to raise it to the third power. So this and this are equivalent. And in fact, you could solve this. The square root of 9, at least the positive or principal root of the square root of 9 is 3, and 3 cubed is 27. And in fact, even if you type that into a calculator, 9 to the 3/2 power, it will still give you back the same answer, positive 27. So let's try a few examples. So here we're going to work on converting from one form to the other. So again, there are two forms here. There are two different versions of the radical form. Typically, we'll use this first one, where it's an nth root raised to an m power, but you can also bring that exponent inside the radical as well. So these end up being equivalent. But let's go through some examples. So here, we're given something in radical form, and we're going to write it in fraction exponent form. So as we look at this, remember, the index tells us the root. So that is the bottom of our fraction. So that index of 5 goes in the bottom of our fraction, and the power we're raising it to goes in the top. 16 to the 2/5 power. Okay, very similar here. This time, though, we do have a whole expression inside of our radical. So we're going to need parentheses. Parentheses, the quantity 3x squared. Remember, our root goes in the bottom, and then the 4 it's being raised to goes in the top. 3x squared all to the 4/3 power. And lastly, the square root of 29. Remember, the square root is the same thing as the second root. Remember, if they don't write that index, it means the square root or second root. And if you don't see parentheses to anything, it's like parentheses to the first power. So we can think of this as 29 to the, remember the root, which in this case would be the square root, goes in the bottom. And the power raising it to goes in the top. 29 to the 1/2 power. It's the same thing as the square root of 29. Okay, let's try some where we're going to convert the other direction. So now we're given these in radical form. We want to write them in exponential form. Sorry, in exponential form. We want to write them in radical form. So the other way around. So how would I write 8 to the 1/3 as a radical? Well, remember the bottom tells us what root. So this would be the third root of this value of 8 raised to the first power. Remember the top number is our power. Well, if it's anything to just the first power, we don't really need that. We can just write it as the cubed root of 8 as our final answer. Okay, let's take a look at this other one. 5 to the 3/2. So remember the bottom tells us what root. So this is the square root of 5. And we're raising it to the third power. Okay, so alternatively, remember there's kind of two forms. I could have that 5 on the outside, or sorry, the 3 on the outside, or bring it in on the inside. This is also equivalent. Also for square roots, we typically wouldn't need to write the index there, right? Remember that's assumed to be 2. Or as the alternate form here where you can bring the exponent inside, we could say this is the square root of 5 cubed. Okay, so either of those last two would probably be the recommended final answers there. Okay, let's do our last one down at the bottom. So notice this time they've given me a fraction exponent that can be reduced. And yes, absolutely, you can reduce them just like normal fractions. So in fact, we'd want to do that first. Always want to reduce when we can. Dividing each by 2 gives me 2/3. So now remember the bottom number, 3, tells me what root. We're taking the third root of -27 and raising it to the second power. Okay, so actually this does have a whole number answer that we could find. So did number 7. Remember, this is saying what times itself 3 times gives me 8, or if we looked for perfect sets of 3 in the factors. Well, if you did break down 8, you'd find exactly 3 2s. So if you wanted to go ahead and simplify it or evaluate it, its value would be 2. But this would be its radical form. Same idea here. What number times itself 3 times is -27? Well, this would have to be -3 times itself 3 times. So the inside of this, and again, this is all we were looking for in this question, was the radical form. We could stop here. I'm just adding in some extra detail here. That this would really be the inside of the parentheses would evaluate to -3 times itself twice is +9. So that would be its value in the end. If you typed this or this into a calculator, and you do need the parentheses here, that would be important, it will give you back +9 as your answer. Okay, last part here. We're going to use rational exponents to simplify. So first thing you notice is we're in radical form. So let's change it to exponential form. So remember, this tells me what goes in the bottom of my denominator. So inside of here we have x, and the 4 goes in the denominator. And remember we said you could have two forms where it would look like this in a radical. So that exponent, the power we're raising it to, could be inside, and that's what we have in this case. So the power, rather than normally being outside of our parentheses, is written on the inside. This is x to the 6th fourth. And we can simplify this fraction, right? Dividing each by 2, we're going to get x to the 3 halves. And that would be our exponential form answer, or we could write it as a radical, which would now be the second root, the square root of x to the 3rd, or if you wanted to bring the exponent inside, the square root of x cubed. So 3 different versions here, depending if it was asking me for exponential form or radical form. The first one is exponential form, this guy. And then these two at the end are radical form versions. Okay, so let's try one more. Here we've got 8. We know that our root is 6. And if we don't see a power here or on the outside, we can think of it as being to the first power. This is 8 to the 1/6, and I think we can do a little bit more actually, because I might recognize, we used this earlier, 8 is 2 cubed. Right? It's 2 times 2 times 2. Think about its factors, which you could write as 2 cubed. And now if we're doing a power raised to a power, if you remember our properties of exponents, you can multiply them, which would give me 2 to the 3/6. And reducing that, dividing top and bottom by 3 to reduce, we get 2 to the 1/2 power, or the square root, right, the second root of 2. Remember, for square roots, we don't need to write the index in there. So 2 to the 1/2 power, or square root of 2, is the same thing as the 6th root of 8. Much simpler version to get the same value. Okay, so let's try this last one. 49, you might recognize, is 7 squared. In fact, if I rewrote that as 7 squared first, and then we change this to our rational exponent form, remember the 4 would go in the bottom of my fraction. And in this case, this 2, like we talked about earlier, it's like the m being in here, would go on top. And if we divide each by 2, we get 7 to the 1/2. It's our exponential form, or the second root of 7 to the first power, or the square root of 7 to the first power, or just square root of 7. And that's it. The 4th root of 49 is the same thing as 7 to the 1/2, or the square root of 7. Okay, so we learned about how to change from exponential form to one of our 2 radical forms, or vice versa. And we looked at how to simplify radicals that aren't just square roots, right? Remember that index tells us what size set we need to make, or to take something out of my radicand.